Alright, so let me show you how to solve a linear inequality by graphing it. And it's very similar to solving um, a linear equation by graphing. You can look at all the points that are on the line or that satisfy the equation. Except you get to do some shading, so it looks a little cooler. Um, so I want to know what does it mean to solve it? I basically want to know what are all the numbers that would make the inequality true, or what are the numbers that satisfy what the inequality is talking about. So, for example, here's the inequality: y is less than or equal to 2x plus 5. So I want to know what are all the values of y that are less than 2 times x plus 5. So you know that's best to just visualize that and see, because actually there's an infinite number of numbers that fill that. So yes, so let's graph it. The first step would be to graph your boundary line, and to do that, you just pretend that this is just your run-of-the-mill linear equation. So instead of y is less than or equal to 2x plus 5, you would just say, pretend in your mind that it's y equals 2x plus 5. That's in the slope-intercept form of an equation. So you know that the slope is 2, and you know that it crosses the y-intercept at y equals 5, or y equals, that looked like a smushed spider for a second. Yeah, 5 equals 5. Brilliant. That's the y. Man, I'm struggling. That's the y-intercept. Okay, so I can use those facts to graph the boundary line of this inequality. So so let's find the y-intercept first. So 1, 2, 3, 4, 5. And then the slope is 2, which I can rewrite as 2 over 1, because slope is the change in y. This little symbol means change over the change in x. So slope of 2 over 1 means I go up 2 and over 1. So I can go 1, 2, and over 1. Now I can connect the lines, or the points, I mean, to draw my boundary. So let's do purple. Okay. Now the question at this point is this line going to be a solid line or actually a dotted line? Um, it's like when you're graphing numbers on a on a one-dimensional um, number line. If you have something that's x is greater than 5, let's say that's number 5 right there, you would leave that circle open like that to indicate that the solutions don't include the number 5 itself, but anything that's greater than number 5 is fine, like 5.1, 5.000003, whatever. As long as it's not exactly 5 and it's greater than 5, good to go. So this is an open circle. If it were x is greater than or equal to 5, that would include number 5, so that'd be a closed circle. So when we launch into 2 dimensions here, I show the same kind of information, but instead of with a circle at the end, if it's a open line, I'll make it dotted. So if it's an inequality where it's greater than or less than, not greater than or equal to or less than or equal to, I would use a dotted line to show that my solutions don't include the line itself, but anything that's less than or equal to, depending on what the situation is. Okay, I look at my inequality here. It's less than or equal to, so that's the boundary will be closed. It includes the boundary, so I'm going to make that a solid line actually. Okay. The last question is, what side of my line am I going to shade in? Um, and the rule is if it's y is less than or less than or equal to something, yeah, you go below the line, right? That makes sense, right? Um, if y is less than, so this is 2x plus 5, this line. If y is less than that, it's going to be, below it. If it's greater than that, it's going to be above it. So here my inequality is y is less than or equal to 2x plus 5, so I know that my shading is going to be below the line. So, and if for some reason it's not apparent to you from the way the inequality is structured, which side of the inequality, which side of the boundary you shade in, you can plug in a point. Just pick a point on one side of the line. Let's say 1, 2, 2, 3. Plug the x and y coordinates of that point into your inequality. And if your inequality is true when you do that, then you shade in that side. If it's false, then shade in the other side. I think it's easier to remember just if it's y is less than or equal to something or less than something, shade below. And if it's greater than or equal to, then shade above. And if you don't have where it's y is less than or equal, if it's like here, you can see in the slope point form, you can see that you could just move this 3 over there and be y is greater than blah 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 blah. So you would shade above the line. Yeah. Okay. So I'm going to shade below the line here. So I'm just going to do something like that. You can use a crayon or a pencil or something if you're doing this on paper. If you're doing this on the computer, you can do something like I'm doing. Alright, let me just actually bring this to the front so it's easier to see. Okay, so there would be, this is not, oops. Okay, I moved the line a little bit, but you get the idea. So this line is splitting the coordinate plane into a half plane, or 2 half planes. I'm shading in this half plane, and my solution set to this inequality is this half plane that I'm shading in. So any value over here would satisfy this inequality, would work for it. So okay, why don't you check out this equation? Or inequality, excuse me. This is in point slope form, which means that 3 is the y coordinate of a point on the line, and that 2 is the x coordinate of a point on the line, and that 4 is the slope. If that doesn't make sense to you, if I'm speaking gobbledygook right now, you can just convert this into slope-intercept form if you're more comfortable with that. Yeah, so graph the boundary line first, determine whether it's going to be a solid line or dotted line, and then if it's greater than, shade above, if it's less than, shade below, and you are done.